On a wonderful afternoon, after the electronic course subject class, Kim Irla, an electronics technologist student, have decided to reminisce and asks questions about the derivation of various formulas, serving as a review for their upcoming term test. Kim Irla really likes to ask questions, and it has become her hobby to untangle certain theories by clarifying the root of certain things. While Kim Irla is walking into the pathway, she stopped by the locker area to check her unfinished projects. She then realized leaving her copper-printed circuit board in the locker for 5 days after soldering it. The copper PCB is brightly shining and working as it was designed on the circuit's layout. But then, the moment she looks at her board's appearance this time, the board's reflective surface is turning into orange-brown. Kim Irla has also observed the soggy manifestation on the copper-printed circuit board, along with the sticky flux left on the board due to the previous soldering that was done. Kim Irla is starting to doubt her copper PCB with the arousing depleting qualities. She is a bit afraid of cleaning her copper PCB, for she has no idea on how to get rid of the following issues. To overcome uncertainties, Kim Irla proceeded to the workshop room and has consulted their veteran professor regarding this matter. His professor told her that the room temperature on that certain area has an adverse effect on the copper-printed circuit board, and the moisture that have accumulated on the closed space of the locker feeds the risk of the board's depletion in terms of quality. When there is an oxygen and metal bonding, there will be oxidation that will eventually lead to corrosion. Meanwhile, the soldering process leaves a flux residue known as flux leftover. These leftover flux causes low-voltage insulation short that provides a current path between conductors and where it is applied, such as IC pins, that creates short circuits on closely spaced conductors. And as they have tested the copper PCB, some connections have short circuits, which is quite dangerous. These occurrences produce undesirable output, so the professor has suggested Kim Irla to limit her usage of soldering paste and have given her techniques in cleaning a copper PCB. On the next day, Kim Irla have a case study to report in class. The topic that was assigned to her is the method of cleaning copper-printed circuit boards. Kim Irla discussed that cleaning the copper-printed circuit boards is essential before integrating into the prototype itself. Polishing the printed circuit boards removes harmful contaminants as well as protect the conductive surface of the board onto the natural factors that therein exist. A metal corrodes at a much greater rate under humid conditions. This happens because the moisture-saturated air reacts with oxygen and electrons on the surface of the metal. The longer metal components are exposed to humid air, the faster they will generally corrode. The cleaning of copper-printed circuit boards is essential to ensure trouble-free performance and the longevity of the circuit boards. PCBs accumulate dust easily, and when exposed to harmful environmental agents, the components on them can deteriorate significantly. After soldering, a considerable amount of flux residue gets left around the solder joints. This can corrode the solder joints gradually and prevent heat loss, which causes overheating. In order to achieve good insulation resistance and improve the lifespan of the circuits, cleaning chemicals should be used. In order to overcome this event, the group of technologists have conceptualized an automated machine that offers a complete guide in the cleaning and polishing process of a copper-printed circuit boards with a more efficient and fast phasing processes. A post-soldered single-sided copper-printed circuit board with adequately mounted components with properly trimmed terminals will be inserted to our machine, proceeding to our very first process called as the brushing process, which eliminates the excess flux residue and dirt that has accumulated on the copper PCB by gently rubbing off those contaminants with a soft bristled circular brush. After the first process, the copper PCB is free from excess flux but expected to attain damp surface due to the thinner solution. In this instance, the copper PCB will proceed to the second phase known as the drying process, in where the air blower will dry the lacquer thinner solution and prepares the copper printed circuit board to the next phase, which is the coating process. With the aid of the peristaltic pump and the full cone nozzle, the standard 4x4 to 4x6 inches copper PCB is considered to accumulate an even distribution of varnish, and proceeding to the curing process, which solidify the varnish from the coating process and therefore yielding a more reliable and effective copper printed circuit board as the core of the advanced technologies. The conceptualized technology of the group of students from the Bedelex 3A focuses on the objective of improving the function, shelf life, as well as the reliability and versatility of a post-soldered single-sided copper printed circuit boards. This automated machine is highly favorable to electronics students and professionals inside the university. The group also aims to transfer the advanced technology to the public and private sectors of PCB manufacturing companies in producing high-quality standards in terms of technology development and in this business competitive era. Expressing the axiom of John Ruskin, quality is never an accident, it is always a result of an intelligent effort, may be the reason why quality is most remembered long after the price is forgotten.